Okay, so today we are going to do a review of for this quiz. So I suggest you take notes because not everything is going to actually be on the slides. Some things I'm going to say, and you'll need to write that down. Everybody got me? All right, here we go. Okay. All right, so sorry, I got to plug something in. So let's start with this. All right, that's not working. All right, this is going great. All right. All right, so what are the three different states of matter? Solid, liquid, and gas. So we have these three different states of matter. So if you were asked to tell the states of matter on an ice cube, particularly a picture like this, it's not just one state of matter, is it? So what are the states of matter we would see? We see a solid. A solid is here, and then we have a liquid, correct. So if you're asked a question about states of matter, should you answer with something about volume? No, you should not. All right. Let's say we're making two of these following molecules. So we are making two of them. So the first question is, how many sodium would we need making two of these molecules? How many sodium would I need? Yes. Well, we're only making two. Is there a subscript after? One, right. There is no subscript here. No, we're making two of them. So each molecule has one. You're right. But if we're making two of them, how many do we need? Two. Are you able to see from back there? Okay. All right. And then how many hydrogen would I need to make two of these? Chelsea? Two, correct. And how many carbon? I see two here. And then here's a kicker. How many oxygen do we need? Yes, we would need 6 because we're making two of these molecules, and each of the molecule has 3 oxygen. Very good. I'll let you get that caught up, written down. Make sure you write down what I said. It will help you. So you'll need to know how many sodium atoms, how many hydrogen atoms, how many carbon atoms, and how many oxygen atoms. Okay. I'll be posting this video on the classroom. So, as we're moving particles, as the particles move apart, what happens to the forces? Do they get stronger? Do they get weaker? Yes. They get weaker. Think about a solid that the forces are so strong we can't move through it, can we? But a liquid, it's not as easy to move through as air, is it? They have a little more force between them, but we move through air without even thinking about it. Move through gases. So as the particles move apart, the forces get weaker. Okay. Which state of matter has the most potential energy? Gas, liquid, or solid? Do we remember? A gas. A gas has the most potential energy because the particles are spread out enough that they can move all over the place, right? So gas has the most potential energy. All right. So when we're talking about thermal energy, we're talking about the sum of the potential and kinetic energy, which means we add together the potential energy and the kinetic energy to get a measure of the thermal energy. It's only a few more. There's 4 more slides. Okay. If we add thermal energy to a solid, what happens to that solid? Yes. They move farther apart. That's correct. So as we add thermal energy, the particles move farther apart. What else happens? What happens to the particles besides moving apart? What about the speed of the particles? Yes. Yes, they get faster and they spread apart. That's right. So those are the 2 things that we need to know about when we add thermal energy to a solid. They speed up and they move farther apart. Okay. So when we're measuring temperature, we're literally measuring the average kinetic energy in a substance. That's the definition of temperature, which is different than that of thermal energy, because thermal energy adds in the potential energy as well, doesn't it? So when we're looking at temperature, it's just the kinetic energy in a substance. If your hand is wearing out, I am going to post this on Classroom after we get done. So. All right. So if kinetic energy remains constant, the thermal energy can increase. Why? What do we add in? Yes. Well, what is thermal energy? It's the sum of what? It's the sum of kinetic energy and what? Potential energy, right. So if the kinetic energy remains constant, but those particles move farther apart, then their potential energy will increase, won't they? And then that can actually raise the thermal energy. Yes. Not right now. Okay, last slide. Which one of these has the slowest particles? The solid, the liquid, or the gas? The solid has the slowest particles, right. They're vibrating in place, where the liquid will float past each other and the gas will fly everywhere. Okay, so that is the review for the quiz for tomorrow. If you have any questions, please let me know.